Guys, welcome to Unit 5, Lesson 1. This is our first online lesson, and we're just going to start off with a graphing review. And as I'm going through here, I want you to notice all the different types of functions that we've talked about. So we have a rational function here. We have an exponential function here. So what I want you to do is I want you to push pause as we're going through here and kind of think about what each of these graphs would look like. So this is a square root function. This is a cube root function. This is a cubic function. And this is an absolute value function. So if you'll notice that we have 6 of these guys. And so go ahead and push pause and we'll talk about what each one of them looks like. Okay, so this first one, rational, it has the asymptotes. So if you'll remember, it kind of has the weird things doing that. This one is an exponential, so that's going to make a parabola. This one is a square root, so it's going to be like half of a sideways parabola. Sorry, this looks hideous, but one of those three things. This is a cube root function, so it's going to do something like that. And then the cubic function down here, it's going to have that same look, except it's going to be like top to bottom, where this is side to side. Notice that the square is up while the square root is on its side. So notice the roots are on their sides and the regular like square and cube are up and down. So that's just something to point out. Oh, and we did not do this. This is going to be absolute value, so V for value. So it's going to look like one of those. So I want to start off with the first one. It's the yuckiest one. So remember we had these vertical asymptotes and horizontal asymptotes. So vertical asymptote we got from the x's. So it's going to be at x equals 4. Because if I put in a 4 here, that's going to leave me with a 0 in the denominator, and we don't want that. The horizontal asymptote is going to be out here. So it's going to be y equals 2. So I'm going to go ahead and graph those. So x equals 1, 2, 3, 4. And y equals 2. And so that's kind of the starting point for my graph. So before we do anything else, let's just kind of focus on the graph for right now. So my vertical asymptote is at x equals 4. So I'm going to go away from that. So that's why I did like 3 and then 2. And then on this side, I went bigger. So 5 and 6. So if I plug in 3 here, I don't like that. Let's take that out. Okay, if I plug in a 3 here, then I have 3 minus 4, that's negative 1. And so that makes this negative 1. Negative 1 plus 2 is 1. Okay, let's do 2. So 2 minus 4, that's negative 2, which would make this negative 1/2. Negative 1/2 plus 2 is 1.5. So let's go the other way. So I'm going to plug in a 5 here. So 5 minus 4, that's 1, which makes this whole thing 1. 1 plus 2 is 3. And then 6. So 6 minus 4 is 2. This is 1/2 plus 2 is 2.5 or 2.5. Okay, so let's go ahead and graph these. So 2, 1.5, 2, 1, 2, 1.5 right there. Let's see, 3, 1, 3, 1. 5, 3, 1, 2, 3, and 6, 2.5. So that doesn't really tell me a whole bunch. Like I've just got these random points here. So I need to know that they're going to do something like this. So anytime you have asymptotes, your graph wants to go towards the asymptote. So I'm going to take this and pull it towards the asymptote, towards the asymptote, towards the asymptote, like that. So I did a really terrible job at this, but it shouldn't ever touch the asymptote. It just gets really, really close to it. So I apologize for how yucky that looks. Okay, so I think while we're here, let's talk about the domain and range. The domain has everything to do with the vertical asymptote, and the range has everything to do with the horizontal asymptote. So both of these, everything works except, so in this case, except when x equals 4, it breaks it. So I'm going to say x cannot equal 4, and for the same reason, y cannot equal 2. Um, okay, so if you'll recall, x-intercept is where we set y equal to 0. So I'll go ahead and set y equal to 0 and solve for x. So I think the first thing I would do is move that 2 over. So I have a negative 2. And I want to get this out of the bottom. So I'm going to multiply these two together. So I get negative 2x plus 8 equals 1. I'll subtract the 8. So x equals 7/2. So it should cross the x-axis about 3.5. So let's see. Right there. Oh, that's perfect. Okay, so my x-intercept is 7/2, 0. Okay, so my y-intercept, same concept. I'm going to set x equal to 0. So y equals 1 over negative 4, because x minus 4 is 0. I'm sorry, 0 minus 4 is negative 4. And so I have, you can just type this in your calculator. I have 8/4 minus 1/4 is 7/4. So just to clarify, that's about 1.75. So let's see, it should cross the y-intercept a little bit below 2. And it sure does. So that works. Okay, so my y-intercept is going to be 0. I'll use this one, 7/4. Okay, whew, there was a lot there. So what I want you to do is go ahead and do the next two. So the parabola and the square root function, and that will be in the next video. Okay, thanks a lot, guys.